welcome back. I would like to remind you that you can take part in contests that were prepared for you by our partners in the Expo Zone. So now let's meet another speaker. Hi, Piotr, Przybył.
Hello.
Hi,
How are
hi,
you?
hi. I'm good, good. Thank you. How are you?
Not bad, not bad.
Okay, so I have a quick question for you before we start, like off topic. What was the first thing that you thought about when you woke up this morning?
Okay, so I took a look through the window and I thought to myself, what a lovely weather.
Oh, yes. Yeah,
Yes,
it's
weather
really
today
wet.
is really lovely, but I think thanks to this weather we're going to have even more participants than usual.
Oh, yeah, that's true.
Yeah.
Okay, so thank you very much. Let's surf with Piotr on new stuff that have came up with Java 12 to 15. So thank you.
Hello everyone. So it's October 14th, it's 1400 hours, and today we are going to cover also Java 14, but not only, also Java 12 to 15. So please remember about this talk that it's entitled Surfing Java 12 and 12 to 15. So we are going to merely scratch the surface. We are not going to dive deeply into these versions of Java. Basically, we're short of time. So if you're interested in any deep dives, I recommend visiting my page. I've listed all my talks on Java since Java 9 even. And so, yeah, as I said, I have a personal page called Software Garden. I work as a trainer, IT trainer for a bunch of companies, one of them being Cementis. And I'm self-employed. I'm working just from here as a remote freelance software gardener, and you can reach me on Twitter and Telegram if you have further questions. My DMs are open. And when it comes to Java, I'm so much with Java, this relationship is like really long and long. Even when I'm on holiday, Java is somewhere behind my back, as it seems. And I've been doing Java since version 1.3, and I even backported some code to 1.2 or something like this. Before we actually start, a little safe harbor, this statement or disclaimer, caveat auditoris. So please remember, everyone can make a mistake, including myself. Errae humanum est. Okay, so there were these 4 versions of Java released over the last 2 years. As you can see, they release every 6 months, and this schedule is maintained, and nothing seems the authors or creators of Java to stop this schedule. So I pretty much think we're going to see Java 16 in March 2021 and Java 17 in September next year. So there's always this question, when new versions of Java came up every 6 months, shall I migrate to this new version, this time being Java 15, or shall I just stick to the latest long-time support version? And the answer is, of course, it depends. As a consultant, I can't tell you anything else, but we need to consider a few factors. If your software is already running on Java like 9 or above, like Java 11, for example, why you should stick to Java 11 and not migrate above? I mean, LTS is nothing about technical stuff. LTS is merely a contract or a promise, if you will, given by Oracle and some other companies that at least every 3 years, they will release a version that will be maintained for at least 3 years. And this is what actually LTS means. So it doesn't mean it's like superior or better or whatever. So if you're like deploying your application more frequently than, let's say, once every 3 years, and it should be working according to you, and it runs, you've checked that with the latest Java, well, why not give it a spin on like Java 15, especially given the fact that Java 15 has some performance enhancements. And of course, maybe you should skip some preview features in production because you need to recompile the code, even if there's source compatibility, there's no binary compatibility, and so on and so on. But please remember that neither those non-LTS releases or preview features are monkey soft or banana soft or whatever we call it. They're just, they're solid, they are tested, they reviewed, they are discussed through. really. It's just they release every 6 months, or these preview features are not curved in stone. I mean, they can change, and you need to opt in to use them. Okay, so the coolest features in these 4 recent versions of Java, according to me, you might have your own list, and please keep in mind that this list, I mean, it's ordered, but it's not that the order really matters that much. So in 15, we saw ZGC and Shenandoah in ready for production use. Also, we saw a second preview of records and pattern matching with instance of. In Java 14, we saw switch expressions became mature and ready. And in 15, we saw the first preview of sealed classes. Since Java 14, we also have Java Flight Recorder event streaming. So we might have like near real-time performance monitoring directly from production or any other environment, if you will. We also have help for null pointer exception messages. We have seen some improvements to G1, and also creation of CDS archives is much easier now since Java 13. So let's jump to Shenandoah GC and ZGC. So both are garbage collectors which can keep head heaps up to 16 terabytes. So I think they're pretty big. I remember my first PC having just like 32 or 64 megabytes of memory. So now having 16 terabytes, it's like it's terrible to imagine. So these are garbage collectors which should compact the memory or defragment it, if you will, concurrently. So we don't have these long stop-the-world pauses. So the pauses are really short, and a lot of effort is made to keep them as short as possible. And also the goal, which is maybe not met at this moment, since I mean, because of this asterisk, of course, is that they should be these pauses should be of constant time. They shouldn't depend of anything. They shouldn't depend of the size of the heap. So we can use both these garbage collectors for smaller heaps as well. You don't have to have like terabytes of RAM assigned to your Java process. But for time being, for example, ZGC will make this time longer if you have more GC roots, aka threads, basically. So they are compacting concurrently, or defragmenting concurrently, and for time being they have single generation, so there's no old and young generation like in G1, for example. However, this might change, and most probably will change in the future. So if you see this in, like, I don't know, 2022, please keep in mind that the things might have changed, especially for ZGC. They operate using jitting barriers, so there's some kind of, let's say, sophisticated technology or magic being done, and this magic happens in jitting barriers. And because of these short pauses and concurrent work, there's one thing I need you to understand, and I need to warn you about, is that they are going to use more CPU overall. So if you have a batch process, let's say you're calculating something with Hadoop or Spring Batch, for example, and the only thing you care about is to deliver the result in the shortest possible time, and you don't care if there were any pauses or how long the pauses took. I mean, you can have like a few seconds GC pause and you're fine with that. You just want this bloody report to be generated after, let's say, 20 hours. Maybe you'd like to choose G1, not any of these GCs, because sure, they will have shorter pauses, but this is really meaningful for online processing, not for batch processing. And there's a nice talk from Simone Bordet from Vox Days Ticino, comparing or introducing briefly both these garbage collectors and how to use Shenandoah GC. So, of course, for any garbage collector, it's nice to decide to set the maximum heap size, and then without any use experimental features and so on, since Java 15, we can just say use Shenandoah GC, and that's it. Of course, there are many more switches, tunings like barriers, limits, and hints, but this is the bare minimum I suggest you should use. And Shenandoah operates using forwarding pointers. You can read about this in Shenandoah GC wiki page, or there's a nice talk by Alexei Shipilov about the garbage collector that could, and also nice entry from his blog. And how to use ZGC, well, it's quite similar. You just say use ZGC and you keep this maximum heap size. And ZGC operates based on colored pointers. So each pointer has more or less a color, and it's checked by the garbage collector if the color matches the current GC phase, basically. And again, there's a nice wiki page I encourage you to read, and a nice talk by Eric Österlund about Z garbage collector. And yeah, getting started from Z garbage collector for Java 11, because both these garbage collectors didn't happen like instantly. ZGC was developed by Oracle over the years, and Red Hat was working over the years on Shenandoah GC. So they were both improved. They were both in like experimental features. They are both backported to various JVMs and so on. But they hit like the full operational performance, which of course will be improved in the future in Java 15. All right, so if you're interested, I have a little demo for you on GitHub. So this is a thing called quasi benchmark. It's not a proper benchmark. If you're planning to do like a PhD thesis or something, please don't reference on me that this is how you do benchmark. This is not how you do benchmarks. However, this can give us some insight on how benchmarks are working. So the code is on GitHub. You're able to clone it after this talk. Don't worry. Jarek is co-author of this. You are able to see his talk on performance, I believe, yesterday. So he helped me to craft this quasi benchmark, which is basically doing one thing. It makes GC busy. Sorry. So this is not really that important. We're just throwing some garbage to a memory. And please, in real life, it's not about sorting garbage. It's about making less garbage. So this is just for, like, let's say, science and scientific purposes. Don't try anything like this in production, of course. And when you run it like this or like this, you are able to run JVM using this quasi benchmark to get some measurements. I'm not going to do it right now because we are short of time. However, I should have the results in here. So I was using Java Flat Recorder to record basically the parameters of this execution, and see when we have this automated analysis result for G1, it already shows us that there were quite a few application halts and there were quite a few GC pauses. So when we go here for garbage collections, yeah, you see a nice pattern of the memory being used here on this chart. And when you see there was a GC pause with ID 68, which was the longest, but also the other ones were pretty long. And this the longest pause for G1 was like almost a quarter of a second, so 220 milliseconds. However, when we switch to, well, this Zoom thing interferes, okay. When we switch to ZGC, you see nothing like this happens. So the garbage collections aren't that red. The memory usage pattern is quite different. And when we take a look at the shortest pause, it's like 1.4 milliseconds. Okay, and for Shenandoah, let's take a look at Shenandoah, how it worked in this approach. Yes, see, so the longest pause was almost 2.7 milliseconds, but I mind you, this was the very first pause. So this was this pause at the very beginning, so it wasn't really that much busy. And the next pauses were also at the similar exponential level, so 1 millisecond and something. So when you compare this, like 1 millisecond and something for Shenandoah, or even 2 milliseconds like this, and for ZGC 1 millisecond and something, and you see 200 milliseconds and something for G1, it seems that for this particular case, for my machine, for this setup, G1 performs in terms of length of the stop-to-worth pauses more or less like 2 orders of magnitude worse. So my reading is this: if your environment is about online processing and you need to provide fast responses, and you really care about the how fast your system, your API responds, you might be interested in ZGC and Shenandoah, because these are the nice numbers, as you can see. Basically, so being like hundreds of times faster is really worth trying. So that might be a reason why you would like to switch to, or persuade someone to switch to JVM 15. You don't have to rewrite your code. Maybe you don't even need to recompile your code. If you're not using anything that was removed, like Nashorn, for example, then you should be able just to spin your code, even compile on Java 8, and use it on Java 15 with this new excellent garbage collectors. Okay, there were also some improvements to G1 garbage collector. There were changes to Java 15. So now G1 can basically abort mixed collections if it detects that this particular garbage collection is taking way too long than expected. So previously, when a collection was planned, it had to wait. I mean, G1 had to wait till the very end, roughly speaking. Now it can abort in the middle, so the pauses aren't that long in case of, let's say, performance cache hits, more or less. And there was also a change that G1 can now promptly return uncommitted memory. I mean, basically, if it seems that there was some like a usage peak in your application, and now G1 detected that there is not so much memory needed, it will give this memory back to the system, to the operating system, and that's very nice, especially for nighttime. For example, nobody is using your web application during nighttime, so there were even some. There was even a research made saying that certain applications were given like 85% of the memory back to the system during the night when the application was basically idle. Okay, so we have switch expressions, the next hot topic. It was introduced first in Java 12 with little changes in Java 13. Now we have that as production ready feature since Java 14. It's a standard feature. And what's the difference between statement and expression, my friends? So basically, this is a statement. So if is a statement in Java, and statements are relying on so-called side effects. So to change this value of the value, stupid name, by the way, we need to use side effects. So this cannot be final, for example, because we have the need to set it here to 12 or here to 17. However, the ternary operator behaves more or less like an expression. You see, I could set it here. If I didn't have this code, I could set it here final int, and this would work because expressions always have a value. And I couldn't resist. I mean, there's a shameless plug from Scala because I also do Scala from time to time. As you see in Scala, everything is an expression. So even if is an expression, and that's why in Scala we don't have ternary operator because it's not needed. So this is the idea. You see how an expression versus statement works. So these are the switch statements we all know and which are still there. I mean, they didn't change. Everything will work and keep working. So there's a classic, I would say, C/C++ based switch expression relying on side effects, as you can see. So we're changing the number of assigned lessons for every day. I mean, depending on the enum value that was given here, and you can observe the fall through here. So for the Wednesday, we will also fall through to Thursday and said that on Wednesday we have 8 lessons. Pity. And we can switch that with switch expressions. So this code is much cleaner. See, and when we use this lambda, I call it the lambda style, then we can replace that code we saw previously with just these few lines. So this seems to be much cleaner. And blocks, of course, are still possible. So if you really need to have, like, for example, like a side effect or something, and you are perfectly aware that this a few line statement to return from this switch is like a bit ugly, then you can of course do that instead just of using any break like in Java 12 or using any return which would confuse the readers and maybe even the compiler. We just use the word yield. It's not colored here because of course this JavaScript plugin doesn't understand this new syntax, but let me show switch expressions. Yeah, here we should have this lessons checker. See, this yield is colored to dark blue in my IDE, pretty much just like case is. So you're free to grab this code, experiment with it, and so on. All right, we can also use yield for every case, and then we also have the fall through. So switch expressions don't always need to be used with this arrow style or lambda style. What really matters is this return or assignment to a value. I mean, if you put switch in a context when a value is expected, then it turns into switch expression, basically. And the switch expressions must be exhaustive, of course. If we have a switch expression which is not exhaustive, like for example, let's do that in here. You see, if I'm missing some enum values, then it's going to warn me that not all cases are covered, basically. That's why I either need to add them, I mean these cases, and that's quite easy for an enum, of course, but it's not so trivial for an integer. So if I have something like this, then I guess you are looking for a default. So then you have default arrow and let's say -1. I don't know if it makes sense, probably not, but this is how you can do that if you are switching over integers, for example. All right, so yeah, this arrow is more like lambda style. If you are programming in Java 8, you should know this lambda style already. So it has no fall through, which was like introduced in C or C++, and has yield because you can't use return in switch statements. However, we can still use return in switch expressions. Yeah, that's a bit confusing, and we can still use return in switch statements. Okay, so there are plans to evolve this against pattern matching. So we'll see most probably from Project Amber in the future. I can't tell when, but in the future, most probably we'll see something that will allow us to constructing objects. Let me find something nice for you to demonstrate. Yeah, in the future we might be able to see something like this. See, so we'll be switching over a node, and then we'll be able to also extract the values inside these objects, or to name it properly, we'll be able to deconstruct these objects. Okay, and this will be very useful, or even is already very useful with records. So let's switch to text blocks, another cool feature, which is a standard feature introduced in Java 15 after 2 previews in Java 13 and 14. And again, defining strings as we used to do this still works. I mean, nothing changed in here. We can still define strings as we used to do that. So, you know, these bloody pluses, you know, this bloody \n to keep or to preserve the line breaks, and so on and so on. And this is quite okay. However, when you switch to, like, let's say XML, JSON, or YAML, things start to look ugly, right? Because keeping these tabs or escaping the double quotes, it doesn't look nice. And you really need to understand what's written in here. Like, you need to parse it. That's why, to ease the declaration of multi-line strings or strings having some other characters, now we can have text blocks. And see, you start a text block by 3 double quotes, a new line. Basically, you hit enter, and then you enter line after line, and you close it with, again, 3 double quotes somewhere. And the tabs are going to be removed, and from here, from the beginning, and but the lines were going to be preserved. And if you need tabs, you just need to indent this string. Again, it doesn't look nice here in slides. Let me show you that in the code. We should have it in here. See, so this is how you do that. Instead of doing something like this, this is how we do that in Java 15 onwards. And we can run this example, because why not? Instead of talking, it's better to see how it works, right? I mean, the code is the ultimate form of specification. That's why in code we trust. You see, when we go here, both these pieces of JSON look exactly the same. So this is a hint for you how you can now format your JSONs or XMLs. Instead of something like this, you can just go for something like this. And there are more examples how it works in this file if you are interested. You need to remember that to start a text block, you need to open it with a triple quotation mark. If you'd like to have 3 or more double quotation marks in your text block, then you need to escape some of them using \, basically. And it's also closed by the same token, let me put it that way. And position of this closing token matters, because as you can see, this is very indented. However, this is not indented because of the algorithm chopping the lines. Here you see just 2 white spaces, and here you see 3 white spaces, I mean 3 tabs, so the number is equal, so this is chopped out. However, here you see that when we chop these 2 tabs, there's one tab remaining here. That's why this is indented. If I show you that somewhere under this countdown, yeah, see, this is indented because this tab remained. Yeah. So once created, they can be used pretty much like any other string. So we don't have any new class for string and a new way of handling string. This is just a new way to declare a string, basically a string instance to be precise. And yeah, they have no interpolation. If you'd like to have values injected like from the scope when the string is used, you can just use string format or string for method. So if you take a look at the string format, it looks pretty much the same as string format. You see, format, this thing. See, so the body of this method is exactly the same as we know it. Instead just of using static method, we can just use formatted method, which in my opinion looks a bit nicer. And this is it. I mean, there's no interpolation like in Scala or like in Bash. So we have something like this. It doesn't basically work in text blocks because text blocks are no raw text strings. There's a programmer's guide to text blocks if you're really interested how it works in greater details. And let's talk about helpful null pointer exceptions, which were introduced in Java 14. However, they were disabled now in Java 15. They are enabled by default. So we have to opt out. So let's take a look at code like this. So of course, this is just a demo code, I remind you. So maybe you don't want to do anything like this in production. However, we have this class A, having class B, having class C and D and E and F, and having a string inside. And we do that and we print this and everything looks nice. However, we pass this object A to another call, or somebody is doing something with this object. And after it's done, what you do is just you try to see the length, the current length of this string kept in this fin object, and it throws a null pointer exception, right? So this is what you see. Even if Java 14, if you didn't enable this. And now the problem is, if you see that in production logs, where on earth is this null hiding, right? Is A a null? Is B a null? Maybe D, I don't know, maybe fine is null, and you don't know, right? So there are two techniques. Basically, one technique is to have this ugly nested ifs. If A is equal null, then report. If A dot B is equal null, then report, and so on and so on and so on. And this doesn't look good, of course. And the other technique is to split this calls dot by dot to separate lines. So then you see which line this null pointer exception really was thrown. Or what you can do in Java 15, or when you enabled it in Java 14, you can just see this very nice message. And it says cannot read field F because A, B, C, D, E is null, meaning someone replaced our object kept as E, I mean this object, with a null. That's why we saw a null message here. And yeah, so that's why we have this this message cannot read field F because E is null. So this is this helpful null pointer exception. And one thing you need to remember, it doesn't say anything about what it was said. I mean, who and when caused the null. It's only about the consumer. So it tells us I cannot read this field because it is null. I can't tell you when it became null or who made it null. That's a thing you can trace and have to trace on yourself. Okay, so now we'll be talking about preview features, which are implementation of JEP 12. And roughly speaking, they all come down to using this flag -- enable -- preview. I'm sorry, we are really short of time, so I'm not able to make a proper intro how they work. However, there are some slides for you, and there's a video for you. If you're really interested, you can trace them. Roughly speaking, what you need to do if you decide to use preview features like records, for example, or pattern matching with instance of, you need to enable this feature for compiler and for the JVM, so that it's used by both, and you need to stick with this version. I mean, if you compile this code with Java 15, for example, and nothing changes regarding records till Java 16, still you need to recompile this code. Okay, so let's talk about pattern matching, for instance, our preview feature introduced Java 14. So we all know this code. We'd like to like double an object if it's an integer. So we ask our compiler, hey, Mr. Compiler, please tell me, is this object an integer? And the compiler says, yes, you're permitted to enter this block. And then when you enter this block, you can't just do integer or object times 2, because the compiler would complain, whoa, why are you trying to multiply an object? I mean, I can't multiply an object, but you told me it's an integer. Forget about it. And this is how the story goes, right? So we need to use this ugly casting. And since Java 14, we no longer have to. I mean, if you're using preview features. So now we add just an alias to this object, which is matched as an integer. That's why it's named pattern matching. And once we have this integer, an alias here, we can just use times 2 and forget about this ugly and noisy casting. Some say it's smart casting. Why? Because of this, because it can also use like the logic, you know, and so on, and shortcutting. See, if we identify object, we all have this string utils bloody class with this method, right? We all have it. So we want to see if it's an object which is a string and it's not empty. Right, so we check if it's a string, and then we alias it as str, and then we use this alias in subsequent parts of this logic expression. So we say, and this string is not empty. So as you can see, it can be used not only in ifs, also in like everywhere where you rely on this alias in this scope, basically. It won't work for all because it might be another object, obviously. Okay, records. Records are preview feature introduced in Java 14. We now see in Java 15 a second preview, and records are a new type of type declaration, and record is a restricted form of a class. I like to think about records or a record as of a cousin of enum, right? We saw enums in Java 5, now we see records in Java 14, and basically it's a class, and you have instances which are objects. However, there are some restrictions on them, right? And they all implement or extend, better said, Java line record. However, you can't say that explicitly, it's done implicitly. And this is how you define a record. So if you have a complex number, in Polish it's called liczba zespolona, and such a complex has a real part and an imaginary part. So we can have a square root of -1, basically. And instead of saying class, you say a record, then you say the name of this class, and then we have a new thing, and it's called the object or the record header. And in this header, you basically say or enumerate all the components of these records. And based on these components, quite new things are going to be generated, because you're going to see them as fields. We're going to have accessor methods. They're going to be used in toString method, in equals method, in hashcode method, and also we're going to have them in constructor. So just with this line, we're going to have that. Oh, let me open the code. The code should be another subproject. Yeah, so it's here, Java. Yeah, so we have the hello. Right, so we have this is the complex method. You see, I just, record I just shown you a second ago. And here, this is how you can use them. So we have a new complex number, and we have another complex number. And because of this method, which we are able to add, because records are restricted, but they are not restricted from having custom methods. For example, we can multiply them. So let me run this code. See, so this is what it says. It says hello records, and this is the result of this multiplication, and this is saying or introducing this record. You can get these values from these components or fields if you like this, like record, see, and you can get real, or you can get record imaginary, and so on. And if you don't, I mean, I didn't like the default toString method. Let me show you that. I see I comment this out and run this code again. And this is the default method. So, see, so this is a very nice description for an object in Java in general, but I don't like this. I mean, this is not how I was taught at university to write complex numbers. That's why I have overridden this method, right? So I have different toString. And you can also override other methods. There's no problem with that. So records have a name, and therefore they have also a type. They have components, if you wish. They have these components then turned into or stored in private file fields. They have generated accessors, and that's the thing. See, I don't have here in Hello Records. See, I don't have any get real. It's just real, or I don't have any is for booleans or was or has been or anything like that. Accessor more or less works like a getter, only without this get or is prefix. Whoa, sorry, we need to go back. Yeah. And we have a generated constructor, canonical, I mean, with a whole list of parameters. So you were able to see that here. Yeah, I'm calling this canonical constructor. In this code, you don't see any constructor to be defined, right? These are just 3 methods and toString, a 4th one. And they also have this equals hash code and toString generated as well. Records can define constructors. I mean, you can add your own custom constructors or compact or canonical ones. And to put some extra logic, if you will, you can also implement these generated methods on your own. However, they need to obey and behave properly. I mean, you need to have proper signature of this method. You can have extra methods like I have this add or subtract or something. You can have static fields and methods. You can implement interfaces. What you can't do with records, though, is that they cannot extend any classes or they cannot be extended. See, you can check this out on your own, like we have these limitations. Right, so for example, let's say you have this nasty idea of extending Java util date, pretty much like Java SQL date. However, it's not possible in case of records because extend clause is not allowed for the record. So they can also have setters. You really need to have something like a kind of mutable field, but they cannot have like a regular setters. You see, once I have this int field becomes private and final. That's why I cannot override this method. That's why I can have any set setter like this. I mean, mimicking this accessor or anything like this set field. I mean, this won't work. It works only if this field down there is mutable. And we can observe it somewhere like here. So we can see, for example, atomic integer, and this atomic integer, of course, is mutable field. That's why I can, for example, have a bump method which just bumps the value kept in this counter. Records also can't have any extra instance fields, and records, remember my friends, records are not Java bins, so they don't have getters, they don't have setters in general. They are very nice for immutable, as immutable data carriers. And they are just POJOs with accessors, and you can think of them as named tuples. So for example, in SQL, we have tuples represented as rows. In Scala, we have tuples. Only in Java, records are named, and therefore they have their own type. Nesting records is very nice. You can nest records just like static class, and they are very, very handy because they can also be local. They're very handy for like stream processing, for any kind of intermediate data representation. For example, let me do that here. See, I have this very nice count and sum record, and please notice it's defined inside a method main. So it's not defined outside. It's not a nested class. It's not a class defined in the same file, but not being public. It's declared inside this main method. So when I run this code, you can see this count and sum being used, because then I use it here. As you can see, as a result, I use its constructors and so on and so on. So if you need such a record instead of such an ugly looking class like this class, for example, you see, you can use just records. So see how much code we have saved, and I assure you this is just the shortest possible version to handle this example. I mean, it's not a proper bean. We don't have setters, getters, and stuff like this. More on records on my blog page, so you can you're invited to follow my articles on records. And let's talk about sealed classes. Okay, so sealed classes are a preview feature. It's introduced in Java 15, and when you don't want somebody else to extend your classes or implement your interfaces, and you can't make them non-public because you'd like to have your classes public, only you'd like to be able to say, hey, this class is public and it's not final, but it's only me able to like implement it or extend it in certain enumerated cases. And this is where sealed classes, or better said, sealed types are for, because this is also about interfaces, not only classes, of course. So this is just meant to prevent bad or unintended code reuse by inheritance, because inheritance is very nice for modeling reality. It's not nice for code reuse. Like you shouldn't extend or implement any type just to have a code reuse. You should do that because you'd like to model or design your domain, for example, like this. So when we take a look at this little diagram, what it says, for example, this is your library. You have a library author, or you're crafting like a core part of your domain in your code, and you have this library type, and you have two, which is an interface, and you have two types implementing this, and then two types extending this abstract implementation. That's fine. That's why I set green arrows here. However, you don't want anyone outside of your core team, for example, to extend or implement these types, like this type or this type. Then you make them sealed, basically. However, using them is still possible. I mean, they are visible because they are final and so on. So that's why you have these aggregations or usage lines drawn here. And this is how it looks like. So now we have interface, library type, and we add sealed in front of interface. And since we have sealed, we need to say or enumerate the permitted, let me put it this way, children or descendants of this library type. So this is an enumerated list. We say that this type is sealed, and we permit two types to implement it. So again, we have sealed type. See this abstract library type here, and it implements this library type, and because it's sealed, it just permits other two types to extend it. And because these two types are final here, then we don't need to seal them, because like final is like its ultimate form of being sealed, basically. And we also have a final class. You can also have unsealed, or sorry, non-sealed with a dash in the middle, non-dash sealed, which will means that then you opt out from this sealing, and basically everyone implementing or extending this class can do that. That's why this doesn't work. You can't use the library type implementation. See in this code, you cannot extend this or implement this. It's forbidden. A compiler will throw you an error when you try to do this or when you try to do this, because user library type implementation is not listed in this permissions, and it's not listed in this permissions. However, what you can do, you can keep such type even if it's sealed as a field type, or you can take it as a method parameter, and so on and so on. So sealing relates to inheritance only, has nothing to do with usage, basically. So now we also have Java Flight Recorder event streaming. This is a standard feature introduced in Java 14, and it allows us consuming the events produced by Java Flight Recorder in almost near real time. I'm saying near real time because events, as the name implies, always tell you about something that just happened. So we cannot have an event saying, oh, garbage collection is taking place. You always get an event saying garbage collection took place, and it took, I don't know, 2 milliseconds and stuff like this. It's possible to use that in your own process as an agent or as embedded. I mean, if you just declare this code, why not? And it's possible to use it out of process, like reroute, let me put it that way, this event stream through a disk with the JCMD and so on. And there's also AppCDS, and there are also AppCDS enhancements in 12. Each JVM should come with their core classes just dumped, so you don't have to create a CDS archive for JVM since 12 anymore. And in 13, we have archiving classes at exit. Basically, it means that generating the CDS archive is much, much simpler than it was before for Java 11 or Java 12. And AppCDS can be used if you're really concerned about your application startup time. Some stuff, of course, got removed, so we don't see concurrent mark sweep since Java 14. We don't see NAS for JavaScript engine, and we don't see Solaris or Sparked JVM since Java 15 as well. And now this is my constant request after every talk. Please always provide feedback for every speaker at every event. This will get you and give you better talks and better topics next time. So provide your feedback in any form, either to the organizers, I mean ProIdea, the organizers of JDD, or if you are, I don't know, concerned about anything, you can feel my own private, let me put it that way. Paul, it's so private, I even don't know your name unless you put it inside. If you're interested in further experiments, then you can clone one of these 4 repositories. So there's deep dive from Java 12 to Java 15. The code is on GitHub, it's public, you can just experiment and so on. If you'd like to not only to learn something by listening, but also by doing, you can just let me know and we'll have a workshop together, because why not? Or you can have a nice quiz from the other. And that's pretty much it when it comes to surfing Java 12 to 15. Thank you very much. It is, I mean, the slide for links is here. This is my Twitter handle. If you'd like to ask me some other questions, let's say privately. Okay, so do you have any questions? Let me see. When to stick LTS? Well, there is, okay, elaborating again. So if you are hosting your own application on your own, I mean, you own the whole infrastructure, you create the Docker images and you Kubernetes the Q8, I mean, use Kubernetes, everything on your own, then why not? If you're relying on something like cloud services, and then you basically in some cloud providers have only 8 or 11, then that means you're pretty much stuck. I'm sorry. However, I mean, as you can see, this is the case that we saw for Java 9. I mean, some companies jumped from Java 8 to Java 9 instantly without waiting for Java 11, which was supposed to be LTS, and that happened because in Java 9, we saw a very nice performance improvement called compact strings. So basically, if you had ASCII strings in Java 9, they occupy pretty much half of your memory, of your heap space, basically. So that's why many companies decided to jump instantly to Java 9, and some other decided to jump to Java 11 because of that, because of the performance. See, now in Java 15, if you care about these ice age pauses or stop the word pauses, that when your application is not responding because it's collecting its garbage, then you should maybe upgrade to Java 15 really ASAP because of these 2 awesome garbage collectors, which can help you a lot with online processing. I think we've reached the time limit, so thank you very much. Back to the studio.
Okay, thank you very much, Piotr. It was amazing presentation. You got really good feedback on the chat.
Thank you.
I can see that.
And you're welcome.
I can see that there is no other questions, but if there will be some questions, you can also ping on Twitter, as you said. So thank you very much again.
Thank you, folks, and stay safe.
Yeah, stay safe.